Okay, we will make a start. If other people join, they join and they miss out on the beginning of this session. So welcome everybody. My name is Chris Irwin. I'm the Digital Skills Evangelist based in the library. And today we are going to be looking at generative AI, the basics. So this session is slightly different to the other sessions that I do in that it's going to be more discussion based rather than using specific tools. The last time I did this session, I have notes that actually getting people to use the tools in quite a short space of time didn't actually go too well. So I thought this I'd revamp the session a little bit and make it more discussion based, and then focus on using actual tools in some of the other sessions that I do. So let's have a look at the learning outcomes for this session. So today, by the end of this session, you will hopefully have a basic knowledge of the evolution of AI to 2025, understand what GenAI can and cannot do, and also have a general understanding of how generative AI tools work. And a bit of a disclaimer, this is a huge area to cover in an hour. AI is constantly evolving, constantly updating. In the past 2 years, it has become this huge area of interest, and it's very easy to get overwhelmed. I was just saying to Caitlin there this morning that it's impossible to keep up to date with all of the developments in this area, even just looking at it from a higher education perspective. So if you have any disagreements with what I say, or if you have anything to contribute, please do feel free to pop it in the chat or just unmute your microphone and comment. Like I say, I want this to be a bit of a co-learning exercise for all of us. So we will start with a WooClap poll, which is how I like to tell me about it. Like, I just discovered an amazing AI tool last week from Google, which I had no idea existed until I was scrolling through Reddit, and it's amazing. And I had never even heard of it. It's from Google, huge multi-million, billion-dollar corporation. So we will do this WooClap. I'll just pop the link in the chat. Or you can scan that QR code if you'd rather do it on your phone. And we've got a few WooClap questions today. Sometimes I think they're a bit cheesy, but it's always fun to get an idea. So first of all, we've got our confidence poll, which is very basic in all of my sessions. I do it in all of them. How would you rate your current confidence level around AI? Maybe you're completely new. This is a basic session, so that is the intention. Or maybe you've already used AI tools quite a lot and you think you're an absolute expert, in which case we're unicorn power. So please do just tap what you think you are, completely anonymous, and we will revisit this at the end, and hopefully you've got a little bit of improvement. But like I say, we're not using any tools today. We're just going to be talking around some of the key aspects, how they work, the evolution of AI technologies. One more person. Give you a few more seconds. No. Okay. I'll come back to that. So I'd like to know, what do you already know about AI? It could be words that you've heard in the media, maybe some tools that you've already used. I've got a WooClap where you can just shout them out, just so I kind of have an idea of what people already know. And then I can gloss over the bits that are already common knowledge in the group, or we can go into more detail. So you can pop the stuff into the chat, you can pop it into the WooClap, or you can just unmute your microphone. And I always find the word clouds, they take a little bit of time to respond. No. Oh, there we are, ChatGPT. Great. That's a tool that we'll be talking about a little bit later. And I think we've got a few. Oh, Research Rabbit, that's another tool. Prompts, great. Machine learning, I think, is one. Yep, so that's kind of a subset of AI. Um, Ask questions, lots of different things coming through. I think there might be a setting in the word cloud where I can change it to sentences rather than individual words. I will double check that. Okay, so we are going to move on. Thank you for your contributions there. So very broadly, the Oxford English Dictionary describes AI, artificial intelligence, as the theory and development of computer systems that are able to perform tasks normally requiring human intelligence. You've got lots of different things there, like looking at visuals, understanding speech, making decisions based on data, and also translation between languages. So I thought we would go on a bit of a history lesson. And AI development kind of starts with, oh, have we got stuck? With this guy. Does anybody know who this person is? You can
Alan
unmute.
Turing.
Very good. Thank you very much. Alan Turing. So he helped in World War II break the Enigma machine code, which really turned the tide of the war. And then after World War II, he published an article called Computer Machines and Intelligence. And in that article, he posited the question, can machines think? And developed a a, I guess, test called the Turing test or the imitation game as a way to determine whether or not a computer is intelligent. And what he meant by that is it indistinguishable from human intelligence in a blind test? Um, and there's a great film called Ex Machina, which explores that concept in a bit of detail. It's a bit sci-fi, but well worth watching if you're interested in learning more about the Turing test. And he was also a gay man and unfortunately committed suicide in 1954 due to the UK's anti anti-gay laws at the time.
He was only given a posthumous pardon quite recently.
Yes, it was only in the past 5 years, I think. It was maybe 2018, 2019. He was treated quite horribly. And yeah, very, very unfortunate, especially because of his role in World War II. You would have thought that his contributions would have been recognized um, before then. So we're going to go back to WooClap now because I've got a bit of an exercise. And we're going to go through these in a moment, but I'm just interested to know what order do you think these AI milestones occurred in? So you should be able to click and drag. I'm not entirely sure what this is going to look like on your end. Um, so we've got some milestones in AI history here, and I'd like you to try and put them in order of when they happened, how they happened. Um, and we'll go through kind of from 1950 onwards. And I can tell you it's probably not the order that you think that they go in. And I'm not sure if on your end it's going to kind of give you the option to, okay, we've got interesting, interesting. One more person. Oh, the last person there. So close. So very, very close. So the correct order is the first computer chatbot, then the first self-driving car, then chess program, then Mars rovers, and then ChatGPT. So you all got ChatGPT right. So we'll go through these and I'll give you a bit more detail right now. So talked about Alan Turing in his article. Later on in the 1950s, John McCarthy, who was a professor of mathematics at Dartmouth College in the US, coined the term artificial intelligence at a conference that was held that year, which brought together lots of different mathematicians, computer scientists in the field. So that's really where we first hear the term artificial intelligence, was 1956. And I'm sure Alan Turing would have been at that conference. However, he was no longer allowed to travel to the US when he was prosecuted for homosexuality. And he, of course, died in 1954. So this was 2 years after his death. And then into the 1960s and 70s. So 1966 was the first computer chatbot called Eliza, and that was created at MIT by a computer scientist called Joseph Weizenbaum. And the chatbot was used to simulate therapy by repurposing user answers. And apparently, lots of participants in that study actually refused to believe that it was a computer that they were interfacing with. They genuinely thought it was a person on the other side. So, that maybe beats the Turing test. Between 1966 and 1972, the Artificial Intelligence Center at Stanford, the University of Stanford, developed a robot which was equipped with sensors and a TV camera, which it could use to navigate different environments. So that's kind of looking at the idea of computer vision and how computers could analyze in real time the input from a camera and use that information to navigate an environment. And then in 1974, James Lighthill, who was a British applied mathematician, published a report which is called the Lighthill Report, which is highly critical of artificial intelligence research. He said it was overpromised and underdelivered, and that report actually resulted in AI research and development funding being reviewed and withdrawn across lots of universities. And that started a period called the AI winter, which, kind of put a hold on big AI development for about 20 years, actually. And, it's interesting to think about where we could have been in terms of AI development had that report not been as critical. So moving into the 80s and 90s, we're in the middle of the AI winter, but that doesn't mean developments didn't happen. So in 1986, a computer scientist and mathematician called Ernst Dickmans developed the first self-driving car, which was a Mercedes van filled with computer kit, which could drive by itself. Admittedly, it didn't work when there were other drivers on the road. It had to be tested in isolation. And yes, it was very successful. And it required a van's worth of equipment in order to process the data that it was bringing in through sensors and through computer vision, but it got up to 60 miles an hour, which is quite impressive for a self-driving vehicle in 1986. And towards the end of the 1980s, you get the emergence of research into neural networks to problem solve. And neural networks are computer programs that are modeled on the human brain's network of neurons. So that's when that research started to emerge and is kind of key to a lot of the AI tools that we use today. And then in 1996, IBM, which is a big tech corporation, developed the Deep Blue project, and that won a chess match, which was 1 out of 6 games. Um, no, wrong way round. 6 games to a match, game, set, match. Yeah, so 6 games to a match, and it won one of those games against current world champion Garry Kasparov. And then the following year, it won the whole match, and the final game was won in 19 moves. To put that into perspective, the Deep Blue AI program could review 200 million possible chess moves per second. So really quite impressive in 1996 and 1997. Moving forward into 2000s and the 2010s, we see the first robot that can simulate human emotions developed at the MIT AI lab called Kismet. In 2004, NASA uses AI to navigate Mars rovers Spirit and Opportunity, without human intervention. And the reason for that being that it takes a long time for data to travel the distance from the UK to Mars. So by implementing AI, it could leave the rovers to make their own decisions on rocky terrain without humans getting involved. In 2011, IBM developed another competition-winning machine called Watson, and that wins Jeopardy, which is a US quiz show, beating 2 former winners. And that AI model was trained on encyclopedias and content from the internet, and it used NLP, which is natural language processing, to process questions as an input in real time and then form responses to those questions. Also, in 2011 was when Apple announced Siri, which was kind of the first smart assistant integrated into phones. And again, that uses NLP technology, so that's natural language processing. In 2012, Geoffrey Hinton, Ilya Sutskever, and Alex Krzyzewski present more research on neural networks and using neural networks for a process called deep learning. And that is the process of AI models taking huge quantities of data and information and then using that data to build predictions. That's one of the, again, another key aspect of AI tools that we see today is the use of neural networks for deep learning. Because of that research, Geoffrey Hinton went on to work for Google, and he resigned very recently in 2023 because he wanted to speak more freely about the dangers of AI development. And he was only able to do that if he quit Google. And then a few more developments in the 2010s. I've got another robotics one. So in 2016, a robot called Sophia was revealed by a Hong Kong-based company called Hanson Robotics. And Sophia was capable of conversation, mimicking facial expressions, telling jokes, again, using natural language processing. So analyzing and processing language as it's spoken, and then formulating a response based on that information. And then in 2017, Sophia was actually granted citizenship in Saudi Arabia, which caused a lot of uproar because now a robot had more rights than a lot of women in Saudi Arabia, which I thought was a little bit of interesting trivia. Also in 2017, Stephen Hawking, who I'm sure you all know, very famous British physicist, warned against AI, saying unless we learn how to prepare for and avoid the potential risks, AI could be the worst event in the history of civilization. So a stark warning from Stephen Hawking there. And then finally, in 2018, OpenAI released GPT-1, which was the precursor to ChatGPT. And the ability of GPT-1 was quite limited. It didn't quite have the ability that we see ChatGPT has today, because the data set was much smaller. The number of parameters that AI model used was quite low compared to GPT-3 and ChatGPT. So in 2020, so that's only 2 years of development, was when OpenAI released GPT-3, and that's what ChatGPT is based on. 2021, OpenAI releases DALL-E, which was one of the first text-to-image generators that became widely available. And then in 2022, you've got ChatGPT being released in November, and that was based on the GPT-3 model that OpenAI had developed 2 years earlier. So what you see throughout that brief history of AI is the kind of continual specialization of different fields of AI. So I've put together this quick infographic to just demonstrate it. You've got AI, which is this much broader area of research. And then as we go through the past kind of 50 to 70 years, this continual refinement and development as research has become available. Of course, and that's kind of proportional to developments in computing power as well. So we've got machine learning, which looks at the ability of computers to learn from data, being trained on a data set. Then you've got deep learning, which is the augmentation of that process using neural networks, which model and which are modeled on the human brain, and how neurons are all interconnected with each other. So you've got these kind of nodes of little computer programs all communicating with each other. And then the final refinement of that is generative AI, which is what we see today. And that's using deep learning models to generate original. I say original in quotation marks because there's a lot of debate on whether or not that content that is generated is original, to generate content based on a user prompt using deep learning techniques. So what is AI? What is generative AI? We've covered that. And what can it do? So I am interested to know some of your examples. I think I've got a woo clap for that. Can you think of some examples or applications of AI that you've come across, of generative AI specifically? Maybe you've used it to help you write an essay. Maybe you've used it to storyboard a film that you've been working on, text to image in Photoshop. Yes, absolutely. It's very powerful, the integration into Photoshop. And even since it was integrated a few years ago, it's become even better. Planning workshops. Yes, absolutely. Reviewing CVs, definitely. I recently used it to proofread an assignment that I'd prepared for a course that I'm doing, but I was horrified at the results that it gave me. It said I did not do a very good job. Generative AI in all Adobe apps. Yeah, so that's still quite limited in terms of the integration. While the integration into Photoshop is very good, I think the integration into Illustrator could use a bit of work. Grok. What's Grok? I'm not sure what that is. Does anybody want to elaborate?
That's the image generator in Twitter, in X. It's Master Stupid one.
I'm not on X. I deleted it when our overlord Elon Musk took over. So I didn't even know that existed. Is it any good? Have you had success with it?
I honestly haven't used it because although I still have a Twitter account, I don't really use it very much. I've got a lot of followers on there, so I publish my articles there. I haven't deleted it entirely, but I don't really use it very much anymore either.
I mean, I don't want to create a Twitter account or an X account just to give it a go, but I am interested. Maybe I can watch something on YouTube about it. Midjourney, another image generation tool. Absolutely. Again, I think I'm trying to think back to my experimentations. I think Midjourney is quite a good one. Certainly when I compared it to Adobe Firefly about a year ago, I think I got the best results using Midjourney. Um, and you'll often find this with lots of different AI tools. You've got the market is so saturated with image generation tools, with text generation tools, and you'll find that some tools work better than others. And that was particularly the case with image generation about a year ago. But I need to do a bit more research to see if that is still the case. So let me just go back to my examples. So let's have a look at sorry, I've lost my window. This is what happens when I don't have all of my usual numbers of screens.
Just going to switch on to my phone so I can start going to university and still listening to this.
Oh. You can always access the recording as well. So some other applications, I guess, are beyond kind of image generation, text generation that you've mentioned here are things like in the automotive industry. So we've talked about self-driving cars a little bit. That uses AI, generative AI to make decisions, and also in sciences, the development of drugs and treatments can use generative AI. And of course, you've got this ability to analyze, huge amounts of research much quicker than a human can. But also you've got AI applications where, that actually synthesizing new drugs to test, new protein sequences for treatments, splicing gene therapies together. So those are some kind of more specific applications beyond what you've maybe come across in your own studies and work. What time are we on? Oh, we've still got loads of time. So let's go back to my PowerPoint. So how do these models work? So I'm going to not try and get too technical, but I do think it's worth being aware of how these tools work broadly, because like any tool that you use, you wouldn't use Microsoft Word without knowing that it's a word processor. You wouldn't use a drill without knowing that you use it to drill holes and screw in things. So it's well worth knowing how these tools work in order to get the most out of them. So you've basically got this idea that there's a computer program that consumes, processes data, which can be put in a variety of different ways. And that data is used to train algorithms. And algorithms are essentially the rules that the computer program uses, the rules that the computer program follows for learning and generating, learning from its input and generating an output. So you've got a few different methods for teaching an AI program to analyze data. You can pop your data in a way that's labeled, and that will teach algorithms how to predict outcomes, how to recognize patterns. And that requires a bit more human intervention because a human has to go through and label the data in an appropriate way to teach the algorithm, so the algorithm knows what to look for. You've also got unsupervised learning, and that uses unlabeled data, and that enables the AI algorithms to discover patterns on its own. So it doesn't require as much human intervention, but if you're not labeling the data, then you've kind of got two sides of the same coin. It could provide insights that are new, discover patterns that nobody has come across before, but then that might also be completely wrong without the context of a human going through and labeling that data. You've also got reinforcement learning, and that teaches algorithms to make decisions to achieve a specific goal within an uncertain environment. And then finally, you've got deep learning, and that is what uses neural networks to learn complex patterns. And with deep learning, you've got all of these kind of different nodes, like I've said before, these little interconnected computer programs that are able to work much more efficiently, much quicker, and kind of bounce, I want to say ideas, but they're not ideas, bounce the data between them to analyze the data and then make predictions to learn complex patterns, etc. So there are lots of different models of AI out there, and you have things for creating text, like ChatGPT, like Google Gemini. You've got things that create images, like DALL-E, like Midjourney, like Adobe Firefly. And what we're seeing now is that you're kind of getting in like integrations of all of these tools within one. So I think if you pay for ChatGPT as a subscription, you can use DALL-E within ChatGPT to generate images. You can specify ChatGPT to present a specific output, whether that be images, a document, etc. And you've also got, what was I going to say? ChatGPT, Gemini. You've also got the ability of integrations like Copilot, which is Microsoft's AI tool, to actually analyze information that's accessible to it within a web page as well. So these tools are no longer confined to the single application that they're kind of used in. They're bringing in models and functionality from across the web using the cloud, using an internet connection. And you've also got kind of AI systems working with each other. So if I ask Siri to do something using Apple Intelligence on my Mac or on my iPhone, sometimes it doesn't always work, and in which case it will ask ChatGPT to give me an answer instead. So let's look at some specific models. The first up is a large language model, and that is what ChatGPT is. It's a large language model. And this is primarily text-based. So it's been trained on a huge amount of text that's been scoured from across the internet. In OpenAI's case, with the training of ChatGPT, they've been quite opaque on where their data has come from. There's an excellent video from their former CTO, Chief Technical Officer. I think it's the Wall Street Journal or the New York Times. The interviewer repeatedly asks her, where does OpenAI get its data to train its models? And she just avoids answering the question completely. It's really quite impressive how she dodges giving that, any specific answer about where it's getting its data from. And you can compare that to other companies that are utilizing AI technologies, such as Adobe springs to mind, where they're a lot more upfront about how they're training their models. And this is a concept we go into in my workshop next week about the ethical issues and responsible uses of AI. Where is the data coming from and how is it being trained? So one specific iteration of a large language model is a GPT, and that is a generative pre-transformer, I think it stands for, which was the model developed by OpenAI. And GPTs as a technology uses a technology called a transformer, and that is particularly good at establishing a meaning from a text input by analyzing words in relation to the words next to it. So you give it a sentence and it can have a good go at establishing a context. And that applies to both spoken word, you can speak to Siri, you can speak to ChatGPT, or typed words as well. So all GPTs are large language models, but not all large language models are GPTs. Moving on to John, is it all right if I mute you? Just going to mute John. So moving on, we've got some image generation tools. So we've got diffusion model, and this is a method for training image generation tools. And what the diffusion model does is it takes the training data, so a series of images, and it gradually adds noise to those images, random noise, and it records what happens, with the idea being that when somebody pops in a prompt to generate an image, it will reverse that process. So it takes random noise and it reverses the process to generate your image. So if you don't know what random noise is, I've got a little video to demonstrate. So here's a picture of a cat, and there's the noise being added slowly, slowly, slowly. And what it is, it's randomizing each pixel to a random color, essentially, until it gets completely saturated with noise. There we have it. And then what will happen in a diffusion model, somebody pops their prompt in, the model will start with random noise and it will reverse that process. So, okay, somebody wants a picture of a cat. I'll look at all the pictures of the cat and how I've added noise and what the results are, and I can then generate an image of a cat reversing that process. And that's one of, I think, the simpler models to understand. And then another generative image model is called the generative adversarial network. And this is a bit more complicated than the diffusion-based model. It does have some elements of the diffusion model in it. But what this does, clue is in the name, adversarial, is it takes two neural networks. One is a generator and one is a discriminator, and it pits them against each other in a competition. And what happens is the generator will try and create something based on a data set, and then the discriminator will take that generation and decide whether or not it is part of another data set or whether it is something new. And if the discriminator wins and it correctly decides that an image has been generated, then it will feed back the issues to the generator, and it will try again with that feedback to continuously try and fool the discriminator until the generator produces a piece of content that successfully fools the discriminator. So I've got a little infographic of how that works. So you've got our generator generating something here, the discriminator deciding whether it's real or fake, depending on its training data set. And as it progresses, it takes that feedback, continuously generates until you've got something that will fool the discriminator. And here's kind of another infographic of how that whole thing works. So you've got our random input into our generator, produces a sample. That goes in, we've got our data set up here, that goes into the discriminator. Discriminator compares the two, and it will decide whether or not the generator has produced something that is worthy of the data set it's been trained on. So this is an example, if we go back to our learning algorithms from earlier, this is an example of deep learning. It's using two neural networks to learn complex patterns and to make a prediction, to create something based on that data by kind of the process of it going back and learning from its mistakes. So, limitations of AI. I appreciate that was quite technical, so try not to get bogged down on it, but I think it's well worth understanding some of those basics. So let's think about some limitations. Let's maybe, if we've got a woo clap, let's pop some limitations in there and we'll see what you come up with. I'm aware John is in transit, so he might not be able to contribute, but if we've got some ideas, we can maybe have a bit of a discussion based on those. Might have to go back into the woo clap. It can be concerns that you have on using generative AI. It can be something that you think AI simply cannot do. Reading.
Sorry, that got really jumbled up
That's fine.
because of the way it's structured. It was essentially providing incorrect or non-existent journal articles for further
Right, I
reading.
see. Yeah.
Yeah, sorry
So
about
when you say it, oh yes, all of the words have finally formed a sentence. No, absolutely. I was chatting to somebody about this last week, who came to another session, an academic in the politics department. She has a very niche research area, and we were using Research Rabbit, which is a tool to, I guess, widen your research pool almost. And she was like, I've got a very niche topic, and Research Rabbit has not given me anything worthwhile to go on because the research topic is so niche. She was like, I could easily just go down a rabbit hole and, spend ages going through all of these articles and none of them actually being relevant. And the other side of that is asking ChatGPT to, have a look into a topic, do a bit of research for you. And I've done this in the past as an experiment, again on quite a niche topic. I ask for an overview from ChatGPT, and it gives me an overview. I ask for sources and provides me with a lovely, properly formatted bibliography of where it's got its information from. I use the library catalog to find some of those sources. Maybe a couple of them exist, but maybe I think, okay, well, maybe not everything's on the Goldsmiths library catalog. So I ask ChatGPT for some URLs, and it provides what looks like a really good URL for a specific book or article. But when I click on it, it just takes me to a publisher's homepage. So it can hallucinate. It can just create references, sources out of the blue that look convincing. And that process is called hallucination, where it creates something that looks factually correct, but actually it's just made it up completely. Or sometimes it actually gets confused. So it interpreted a journal article as a book, or vice versa. It referenced something as a journal article, but it was actually a chapter from an anthology, from an edited book rather. Wrong information we've talked about. Lack of creativity, absolutely. It's a huge argument, especially in creative disciplines. Some people believe that AI simply isn't creative, that it's been trained off the creativity of artists, of designers, um, and yeah, it can't be creative in its own right, which is an absolutely valid point to make. Talked about wrong information. Data privacy, absolutely. Whenever you're using an AI tool, I highly recommend you look over their privacy policy, their terms and conditions, and seeing what they're doing with the data that you're putting into the model. We've talked about I've talked about briefly OpenAI and it just trawling through the internet and not being transparent about where its data is coming from, but also you don't know what's happening to the data that goes into those systems. You know, if I start putting in huge amounts of student data into ChatGPT, you know, what's it going to do with that data? Is it going to use the model to train data, use that data to train the model in the future? So that if I put the student's name in and it brings up a whole list of their, you know, their marks or work that they've been doing, um, or another issue is around data protection, as if I'm putting data into there, is it leaving the European Union, which you know is a breach of data protection legislation in the UK. So there are huge questions about what happens to data that is put into generative AI tools. And as well, think about copyright, which is kind of an offshoot of that. You know, if we've got access to copyrighted journal articles or books through our institution of goldsmiths, and then I just pop a PDF of a copyrighted work into a AI tool, is it going to use that copyrighted data to train its model? That's a huge issue, a huge problem, um, and a huge concern, and that could have huge repercussions later down the line if the copyright holder um, was to learn that had been the case. Making humans be lazy. Definitely. I think I saw a post on LinkedIn just this week about how workers are relying more and more on using AI tools, and it's eroding their critical thinking skills and their ability to, what's the word? And their ability to, I guess, analyze problems, to problem solve, because it's just so easy to just pop something into AI and you know rely on the output. So yes, I think that is a definite issue, and like I say, it's been the subject of a few things I've read about recently. Fab. What time are we on? Right, we're running out of time. So, does anybody have anything that they would like to add? Um, or shall I move on? Fab. So, does anybody have any questions about the content that we've covered today? I appreciate it's been more of a me chatting away with some input from yourselves. And it's which isn't normally my style of teaching. I like things to be practical, but especially when you're online, it's quite difficult to do. I hope you found it a useful session, and if you would like to learn more about specific AI tools, you can come to my other AI workshops. There was one last week about using AI productivity tools to enhance your teaching and learning skills, or to enhance your coursework. And in a few weeks, I've got one specifically on AI tools for creativity. Well, we will be looking primarily at using AI tools for creative practice. So image generation tools, um, using video generation as well, a little bit of that. Does anybody have any questions, anything to add? No? Great. Well, thank you for attending this session. I will just pop up the confidence poll. Hopefully you have increased in confidence. And again, this is completely anonymous. It's just so I have some kind of measure that these workshops are working to some degree. What I'm going to do is while you fill in that confidence poll, I'm going to pop a link to a workshop evaluation survey into the chat. If you would be so kind as to fill that in, that would be really, really appreciated. And again, it's just to gather feedback so that I can develop these sessions for the future. So I hope that you've learned something today. If not anything, that you know now that the first self-driving car came before a chess-beating computer program, which I think is quite a quite a wild revelation when I was researching for this workshop. If you have any questions, you can email me or contact me on Teams. And thank you for coming. I will see you at workshops in the future.